Hello, once again, welcome to another CSE1PES CSE5CES lecture video chunk of content. Today, this is another optional video. You don't need this to perform the subject. You can do anything in C just fine without the switch statement, but it's relevant in the context of talking about if-else and control flow. So I wanted to give you some notes on it just in case it comes up in the future. So we talked a little bit in the control flow lecture, in lecture 5, about doing if, else if, else if, else if, else if, else as a construct. And specifically we talked about how you can have as many else if clauses as you wanted because it's just an if else statement where the statement of the else is another if. So you could have a program that looks something like this. I have abbreviated the program because it doesn't all fit on one slide, but basically the idea is that for any single digit integer that you give it, it prints out the string version of that integer. So if you type in the number 0, it prints out 0, right? ZERO/N. If you type in the number 1, it prints out ONE, new line. Number 2, 2, etc. So there would have to be, how many? 10 ifs or else ifs, and then maybe an else to handle the error case where they typed in something that was not a single digit integer. That's kind of annoying. But this construct is often referred to as an if-else ladder. It looks kind of like a ladder. You can imagine there are rungs. That's what we call it. And the flow chart looks kind of like this. So this maybe makes it look a little bit more like a ladder. So we've got, if expression 1 is true, do statement 1, go to the end. If it's false, else if expression 2, do a statement 2, go to the end. Else if expression 3, statement 3, go to the end. Else if expression n, do statement n, go to the end. Else, statement else, go to the end, you're done. That's what the flowchart looks like for a complicated if-else statement. There's nothing wrong with this. It works, absolutely. It gets the job done. But they do have some issues. There's a lot of repeated typing. So you've got if num double equals 0, else if num double equals 1, print it. Else if num double equals 2, else if num double equals 3, etc. And with a lot of typing comes a lot of potential to make errors. So C provides an alternative syntax to replace if-else ladders in at least some of the situations. And that's the switch statement or the switch case statement. And what that looks like is this. Sorry. What it does is it tests a single variable for equality against a series of comparison values. And what it looks like is this. So switch variable name, you give it the name of a variable, and then case value 1, statement 1, break. Case value 2, statement 2, break. All the way down to default, statement default. Default is optional. It corresponds to the last else in an if-else ladder. If you have if, else if, else if, else if, else if, else, default is that last else. Just like in an if-else ladder, you don't need an else statement. You can just do if, else if, else if, else if. That's it. You don't need default. If variable doesn't match any of the listed values, control flow goes to the default. Okay. So here's the switch statement, the program that we talked about with the if-else ladder rewritten to use the switch case statement. So we have an integer num. We read num in from the keyboard. We switch based on num. That's how I like to think about it. It's not the way you have to, but we switch based on the value of num. If num is 0, we print 0 and we break. If num is 1, we print 1 and we break. If num is 2, we print 2 and we break. If num is 3, we print 3. If num is 4, we print 4. So this is what the flow chart looks like for the if-else statement, or for the switch statement, I'm sorry. So if var equals, double equals, value 1, do statement 1, do break, go to the end. If var equals value 2, do statement 2, do break, go to the end. And you can see that this looks almost exactly like the if-else ladder. We've got a bunch of conditions going down one side, a bunch of decisions represented by diamonds in the flow chart, each of which goes through one statement to the end. Right? They look very similar, and that's for a good reason. They do the same thing. So, what is break, and why do we have to put it in each of our case statements? Let's find out. So the break statement is what C does to exit early. Sometimes you need to stop doing what you're doing and just take a break, right? I'm fed up with it, I've been working hard, and I need a break. Just the same in C. You can skip some statements. This usually happens within control flow constructs, such as loops, and most commonly in the switch statement. So break is the command that does that in C. When break is encountered, control flow immediately skips to the end of the loop or the end of the switch statement. Okay? It jumps to after the control flow structure that you're currently in. So why do we need break? It turns out that this is one way that the switch statement is not quite like an if-else ladder. Without a break statement, control is going to fall through to the next case and execute that statement as well. And the one after that, and the one after that, and the one after that, potentially. Sometimes this is useful. We'll see an example where it is useful in a second. But usually it's not what you want. So here, I did it as, I wrote a little program that takes the last digit of an integer and prints out whether it's 0, 1, 2, 9. And I left out the break statements. So let's see what happens. If I type in the number 9, 9 modulo 10 is 9. I switch based on the value of last digit, which is 9. I come down to case 9, I print 9, and I'm done. Okay? Seems like it works properly. But what happens if I put in 5? So 5 modulo 10 is 5. I switch based on the value of 5. I go to case 5. I print out 5. And then I print out 6. And then I print out 7. And then I print out 8. And then I print out 9. And then I run out of things to print, so I'm done. So the same thing would have done if I had typed in 0. It would print F0. And then because there's no break, it would continue into the body of case 1 and print F1. And then it would fall through the body of case 2 and it would print 2 and so on. So for 0, it would print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, that's not what you want. I should have put in the break statements. But this time I left them out on purpose. So I wrote a little program called grade switch, where you scan in a single car that is interpreted as the grade that you've gotten in a class, and prints out a little message based on the grade that you got. So if you got an A, that's excellent. Good job. I hope you all get A's. Work really hard. If you put in a lowercase a, that is also excellent. And that is because case capital A falls through to the body of case lowercase a because there's no break statement here. So we can use the same body for both case capital A and case lowercase a, for both case capital B and case lowercase b, right? So this is a case where I've done it on purpose because I have two cases that I want to execute the same code, right? So there are cases, no pun intended, where you want multiple case statements to execute the same code. Okay? And then just to show how default works, I put in the grade Z, and it's an invalid grade answered. Okay? That's all there is. So case switch or switch case is an alternative to using if-else ladders for some types of comparisons, for equality-only comparisons. But if you've got a big list where you want to do something different based on every digit or every character or every possible value of an enum, which is something else that we'll talk about, a switch case statement is a really good way to do that. You don't need to know this. Again, this is purely optional. Everything you can do with a switch case statement, you can do with if-else, but it's a way to do it a little bit neater and faster and cleaner for some applications. Thanks for watching. Be well. Until next time.